Good morning, student. Today we are with the new lecture of chapter 2 of class 12 electrochemistry. In this topic, we mainly discuss about the electrochemical cell. So all of you understand the electrochemical cell. Okay? Galvanic cell, it is a very important topic of this chapter. So student, please try to understand about the galvanic cell. Galvanic cells are the device or the cell which converts chemical energy produced in a redox reactions into electrical energies are known as galvanic. Now try to understand the definition of galvanic cell, the cell which converts chemical energy produced in redox reactions, Zn solid plus Cu plus 2 aqueous into Zn plus 2 aqueous Cu solid into electrical energy and has a potential of 1.1 volt when concentration of Zn plus 2 ions and Cu plus 2 ions is taken to unity. Once again, the cell. Now, galvanic cell, the cell which converts chemical energy produced in a redox reactions into electrical energy and has potential of 1.1 volt when the concentration of Zn plus 2 and Cu plus 2 ions is taken to unity is known as galvanic cell. Is known as galvanic cell. Known as galvanic cell. Galvanic cell was designed by a scientist named Galvani, known as Galvani, so it is said to be galvanic cell. And when in a galvanic cells are built up in a two separate chamber in which separately oxidation and reduction takes place. So we try to understand the construction and functions or working of galvanic cell. So let us move with the diagram. So all of you try to see the diagram of the galvanic cell. Galvanic cell is built up in a two separate chamber in which separately oxidations and reduction takes place. All of you see that there is a two chamber, chamber 1, chamber 2. In chamber 1, zinc rod and its electrolyte zinc sulfate are taken. In container or chamber 2, copper rod and its electrolyte copper sulfate is taken, and a salt dish filled with neutral substance like potassium sulfate. It helps to exchange the ions between the two half cells or chamber or container and maintain electrical neutrality and also complete the electrical circuit. Okay. Now, in the cell, the half cell containing zinc rod and its electrolyte acts as anode because here oxidation will take place. And the chamber or the half cell containing copper rod and its electrolyte acts as cathode because reduction takes place. So it is also said to be oxidation half cell, and this one is the reduction half cell. It is said to be the oxidation half cell because here oxidation takes place. Oxidation half cell. Always oxidation half cell is always present at the left side, and there is a reduction half cell. So all of you try to understand oxidation half cell because here oxidation takes place, and all of you know that oxidation takes place at anode. Here Zn solid loses 2 electrons to form Zn plus 2 and release 2 electrons. So here electron is flow, and this side, opposite side, current will flow and there is a deflections are shown in the galvanometer. So in this, all of you seen that there is a production of electricity will takes place. Okay, here reduction half cell, because reduction takes place, reduction always occurs at cathode. Here Cu plus 2 ions gains 2 electrons to form Cu solid. So oxidation half cell, actually this is the copper, and in surrounding copper ions and sulfate ions are present. So in between these two there is a electron difference. So here electrode potential will develop. Electrode potential will develop, and at this electrode oxidation takes place. So here it is said to be oxidation potential. Oxidation potential develops develops in oxidation half cells at the anode, and in this anode acts as negative terminals. Here cathode acts as positive terminals, and then oxidation potential, or in short E ox. When it is measured under standard condition, then it is said to be E naught ox, or standard oxidation potential. So all of you please try to understand, there are the two terms, which is standard oxidation potential. It develops over the anode. Understand? Here oxidation potential will develop, and when oxidation potential is measured under standard conditions, that means temperature 298 Kelvin and the concentration will be 1 m, then in this condition it is said to be standard oxidation potential. In this, reduction potential will develop, reduction potential will develop, and when reduction potential is measured under standard condition, then it is said to be E naught red. So these are the terms related with the galvanic cell. So all of you try to understand. Now once again I repeat, galvanic cells are built up in a two separate chamber, in which separately oxidation and reduction will take place. The chamber containing zinc rod and the electrolyte zinc sulfate acts as anode, because here oxidation takes place, because it loses electrons. And the chamber containing copper rod and its electrolytes copper sulfate acts as cathode, because here reduction will take place. And a salt bridge, a glass tube which is fitted in between these two half cells, it filled with the neutral substance like potassium sulfate. It helps to maintain the neutrality. Suppose that here positive ions is increases or negative ions increases, then it supply either K plus or sulfate. In this way they can maintain the electrical neutrality. So all of you try to understand, the main role of salt bridge is to maintain electrical neutrality during the process. Understand? So all of you please try to understand. Next thing, there is a zinc rod and there is a presence of Zn plus 2 ions, zinc sulfate ions. So in between the Zn and Zn plus 2 ions, there is a potential develops because of the difference in the electrons, and this potential is said to be oxidation potential, because here oxidation takes place. Similarly, in this there is also potential develops between the copper rod and Cu plus 2 ions present in the electrolytes. So in here also reduction potential will take place. Reduction potential will take place, and the potential difference between these two is known as cell potential or E cell. And when it is measured under a standard condition, then it is also known as standard cell potential. Hoping that all of you understand that this is the electrode potential. Electrode potential, the potential difference between metallic rod and its ions is known as electrode potential. And electrode potential is further categorized into two type. Number one is the oxidation potential, number two is the reduction potential. Oxidation potential, here oxidation takes place, reduction potential, reduction will take place, and it is oxidation half cell always present at the left side and reduction half cell present at the right side. So all of you try to understand. And the terms related to the galvanic cell, all of you always remember, which is electrode potential, which is of two type, oxidation potential and reduction potential. And when these potentials measured under standard conditions of temperature and concentration, then it is said to be standard oxidation potentials and standard reduction potential.